This is a brief video on how I identify the circuit responsible for a parasitic drain using a multimeter. It is not about identifying the specific cause of the drain, although in this case I will. As with the previous video, it is important not to interrupt the circuit during your investigation. If you do, you run the risk of upsetting the sleep status of the vehicle, and that can really cause problems in your diagnosis. As you can see, we've got 66 milliamps of parasitic drain now. Previous video did show that at about 17 or so. Now that I know that I've got an excessive parasitic drain on the vehicle, I need to check which circuit is responsible for that drain. The problem can be with modern cars is there's an awful lot of circuits to check. If you don't have specific product knowledge of the vehicle you're working on, then that can prove to be pretty tricky. So what I do is check every fuse in all the fuse boxes for activity. So that means I am not checking to see if a fuse is live and has battery voltage on it, as many will. I'm actually looking to see if current is flowing across a fuse, and as in the previous video where I mentioned, if there is current flow then there is volt drop. So what I will do is check each fuse via its test point for a volt drop. It may be very small volt drop, and we are talking about millivolts, but there will be a volt drop there nonetheless. Some fuses unfortunately don't have test points, and that means you have to be a little bit more creative in how you go about accessing them, but the principle remains. So all I'm going to do is test every fuse for a volt drop. So I'm just going to check every fuse, and as you can see on the meter, a little bit of noise going on there. Do a zero check, make sure that's clear, and then we literally go down every fuse. You've got to remember to hit the test points. There we've got 0.01, no, that's 0. See, that's very important to get that a really good connection. Thankfully this car hasn't got too many. We had 0.01 there. .01. You can see how important it is to actually make sure you are properly connected. And nothing. So now we'll go and look in the cabin fuse box. So I've moved into the cabin, to the cabin fuse box. I haven't disturbed the vehicle, as I've got it set up as I said in the original video. And I go along all the fuses. Again, not always easy to get at, but that's just where you have to be a bit creative. There's 1.01. Getting on the test points is critical. you don't, you get a ghost reading. Yeah. Oh, hello, this one's got something on it, 0.16. Now the highest value I've got so far has been 0.01, but this one, this is a 20 amp fuse, has got 0.16, 0.17. So that one is significantly higher than all of these other ones. So this is the first one I'm going to be looking at. So now I've identified what fuse is the standout fuse, and in this case it's fuse 4 on this BSI. I can now go and look that up in service documentation or the owner's handbook, whichever is available, and identify what that fuse protects. In this case it protects the radio, switch gear around the steering wheel, the clock, multifunction display. So effectively there's 3 components that fuse powers on a permanent basis. So typically then I will go for the easiest to disconnect at the end aligned. You can use a lookup table that will tell you what volt drop equates to how much current across each of these fuses. I don't tend to use it too much because I'm not specifically interested in the value. I'm more interested in the fact that I've got one that stands out much higher than the others. So we can look at the lookup table just to see if it corresponds to the value that we're looking for. But in reality, when I'm working on these things, I'm just interested in what fuse has got the current flowing on it. As you can see, I've set this fault up purely by placing a test lamp in the radio power supply. This test lamp draws approximately 50 milliamps. So now I will remove that and we'll just show what the effect is on the fuse and on the total current. Okay, now I've got the test lamp removed and we'll just check to see what that is, and there we've got 0.03 millivolts. That would be the residual current that flows through that fuse in order to power the radio, multifunction display and the comms 2000 naturally. So we'll just check the total current, and there you can see we're back to our 17-18 milliamps total current. Well, that concludes this video. I hope you found it useful. Thanks for watching.